पावर प्लांट क्वेश्चन आंसर में आपका स्वागत है। अगर आप BOE या बॉयलर ऑपरेटर एग्जाम या इंटरव्यू की तैयारी कर रहे हैं तो यह चैनल आपके लिए बहुत हेल्पफुल होने वाला है। चलिए शुरू करते हैं। What are the two basic types of turbine? The basic of operation principle steam turbines are classified as impulse and reaction turbine. Impulse turbine use impulse force of the steam on the blade to move the rotor. In reaction turbine, shaft is rotated by reactive force rather than by a direct push or impulse. Why is compounding done in turbine? To reduce the rotational speed of turbine, multistage is done. Multiple set of nozzles and moving blades are fixed in series. This is also called compounding. Either steam pressure or steam velocity is dropped in these stage depending on the type of compounding. What is the difference between pressure compounding and velocity compounding? In pressure compounding, the total pressure drop of steam is achieved step by step. Pressure drop across several stage nozzles and moving blades are fixed at every stage. Steam passing through the first stage of nozzles is directed to the first row of moving blades. Exhaust steam of this moving blades row enter the second stage nozzles set and is diverted to the second row of moving blades. It continues till the exhaust pressure is reached. In velocity compounding there is only one set of nozzles. But velocity drop take place at different stage of moving blades. The high pressure steam enter a set of nozzle where the steam pressure decrease and the velocity increase of moving blades. On this blades is guided back another set of fixed blades. Neither pressure nor velocity drop on this fixed blade. This process continues till the velocity of steam drops significantly. What is a reaction turbine? In a reaction turbine, fixed blades are attached to the casing. Moving blades are fixed to the rotor. The steam while gliding over moving blades produce a reaction on the blades. This reaction force produce rotates the rotor. Steam coming out from the moving blades is guided by the fixed blade to enter the next stage moving blades. Pressure drop across both moving and fixed blade. What is the difference between partial condensing turbine and condensing turbine? In partial condensing turbine there are two inlet valves. The turbine acts as two turbines connected in a series. The first portion of turbine is called HP stage and the second portion is called LP stage. Some quantity of steam is bleed out after the HP stage and LP stage. Remaining quantity of steam exhaust in condensate in a condenser. In condensing turbine, steam enters the turbine through a governing valve. After doing work inside the turbine, pressure and temperature of steam decrease. Steam cannot be expanded. The exhaust steam is condensate in a condenser and the condensed is used further at a boiler for formation of steam. What is parting plane? Turbine casing casting is done in two halves. Each half is machined to accommodate the fixed blades, bearings, labyrinths. Two halves of casing are matched at parting plane and fastened by bolts. Metal to metal joints sealing is done to avoid any steam leakage. Where is the throttle or control valve of the turbine located? Throttle or control valve assembly are housed in the steam chest located at the inlet end of turbine casing. Steam first enter the turbine through steam chest. Throttle valve regulates the entry of steam to the nozzle block. What is Williams line of a turbine? Steam requirement varies with the load on turbine. The relation of steam requirement to load is shown in a graph called Williams line of the turbine. Williams line nearly straight shows the steam consumption kg/h versus power output kW for a steam turbine. What arrangement is done for the expansion of turbine? During starting turbine, starting curve is followed for the smooth expansion of casing and rotor. Sufficient time is allowed for the expansion of these parts. This is called soaking of turbine. More time is given to bring the turbine into full speed from cold condition. Why are casing drains provided? During starting or low load condition there are the chance of steam condensation. So casing drains are provided at lower casing to drain out this condensate. Where is the thrust collar provided and why? Thrust collar is provided to take care of axial thrust of rotor during various load condition. How is the axial thrust controlled? What is a balancing piston? The inlet steam pressure is higher than the exhaust end pressure. So, an axial thrust is produced. This is counteracted by a balancing piston. The steam is admitted to a dummy or balance piston chamber. This is a disc-shaped attachment to the rotor. When the rotor is fitted inside the casing, a chamber is formed. Steam is admitted in the counter direction of the main steam flow and hence, a counter thrust is produced on the balance disc. This thrust minimizes the rotor axial thrust. How are moving blades fixed at the rotor? Moving blades are fixed on the rotor shaft by a suitable route design. These rotating blades convert the kinetic energy of steam into mechanical energy to rotate the turbine shaft. Blade roots are fitted into the grooves made on the rotor. Why does the size of blade increase gradually towards the exhaust end? A blade has to withstand higher pressure and temperature at the inlet stage. The pressure and temperature of steam decrease gradually. Towards the last stage of blade, the steam becomes wet and its volume becomes more. So the blade size at the exit stage is larger and it has to withstand erosion caused by the moist steam. Why is the erosion noticed at the last stage blades? A blade has to withstand higher pressure and temperature at the inlet stage. The pressure and temperature of steam decrease gradually. Towards the last stage of blade, the steam becomes wet and its volume becomes more. So the blade size at the exit stage is larger and it has to withstand erosion caused by the moist steam. Why is shrouding provided on the rotating blades of a steam turbine? Tips of the blade are formed into shrouds, which closely contact the adjacent blade. Shrouding is done to maintain rigidity. It reduces vibration of the blades due to the change in impulse of the steam flow. Where is the lancing wire used? Damping wire or lancing wire is fitted at the last stage, bigger size blades. Lancing wire passes through a hole, drilled on the blade. During the rotation of a rotor, this wire contacts the outer surface of the blade hole due to centrifugal force and increases rigidity. What is the profile of a blade? The geometry of a blade or profile is designed to minimize the energy loss. The profiles for different stage of blades are different. It depends upon the steam parameter at that particular blade stage. The profile for impulse and reaction blades are different. What is diaphragm of a steam turbine? The partitions between pressure stages in a turbine's casing are called diaphragms. They hold the vane-shaped fixed blades, which facilitate the expansion of steam and guide it to flow over the subsequent moving blade row. One half of the diaphragm is fitted to the top casing and the other half off to the bottom. Mostly the diaphragm is split horizontally for facilitating assembly. These diaphragms are fixed to the casing by suitable arrangement. What is labyrinth and why is it used? Labyrinth-type sealing is adopted in modern steam turbines to minimize the steam leakage. Labyrinth is defined as a complicated network of passage. It prevents easy leakage passage of steam. Sealing depends on the labyrinth gap and the length of leakage path. What is interstate sealing and why is it required? It is required to provide sealing arrangement between the moving and fixed part of the turbine to restrict steam leakage from the blade system. multiple labyrinth seals are provided at the inner faces between the diaphragm and the rotor. For moving blades, labyrinth seals is provided at the casing to restrict steam leakage from the moving blade and the stationary casing. Seal strips are fixed on the rotor at the groove provided for diaphragm sealing. This sealing arrangement is called interstage sealing. What is gland? Why is gland sealing required? The portion from where the rotor exists, the turbine casing, is called gland. There is chance of steam leakage and atmospheric air ingress to the casing at the front and rear gland respectively. So it is required to seal this portion. What is the function of oil in journal bearing? Journal bearing is a cylinder which surrounds the shaft and is filled with lubricating oil. It consists of a split outer shell of hard metal and a soft metal at the inner cylindrical part layer of lubricating oil, separating the shaft and bearing due to fluid dynamic principle. Oil layers support the shaft, preventing metal-to-metal contact. Why is soft metal or babbitt used in journal bearing? Inner surface of this bearing is coated with a soft metal known as white metal or babbitt. Thickness of babbitt is 1 mm to 100 mm, depending upon the bearing diameter. Babbitt metal contains tin with a smaller amount of antimony, copper and lead. This babbitt lining is a sacrificial layer and provides a surface which does not damage the shaft if contact is made accidentally. What is the main constituent of babbitt material? Babbitt metal contains tin with a smaller amount of antimony, copper and lead. How is the bearing temperature measured? To measure bearing temperature, resistance temperature detector, RTDs are embedded in the bearing and its lead is taken out from the bearing pedestal for further termination. What is the function of thrust bearing? Shaft is permitted to float to both the axial direction. But the axial float is restricted to certain limit. Excessive axial shift may damage the rotating and fixed parts. For this, thrust bearing are provided. What is the function of emergency stop valve and why is steam stainer used? Emergency stop valve is a quick operating valve which is normally hydraulically operated. To open the valve, hydraulic pressure is applied against the spring. To close the valve, this pressure is released by draining the hydraulic fluid. In most of the stop valves, a strainer is provided to restrict the entry of any foreign material into the nozzle of turbine. How is the control valve operated? Control valve regulates the steam flow to the turbine. This valve is placed inside the steam chest of turbine. It is operated by a governing valve which is actuated mostly hydraulically. Why is multiple control valve arrangement made and how is it achieved? Multiple valves make the steam flow control more effective and minimize the throttling loss. It is operated by a governing valve which is actuated mostly hydraulically. The valves are fixed to the lever in such a way that the particular valve open or closed at particular lever position. Depending upon the steam requirement at different load condition, different valves open and the steam flows to different nozzle sets of the turbine. What is socking of turbine and why is it required? During starting, turbine starting curve is followed for the smooth expansion of casing and rotor. Sufficient time is allowed for the expansion of these parts. This is called soaking of turbine. Why is an auxiliary steam used at the gland of turbine? Auxiliary steam is used at turbine glands primarily to prevent air leakage into the turbine and high-pressure steam from escaping the system during startup and low load conditions. Why is a safety valve provided at the gland steam header? Safety valve provided in the steam header to protect the gland from excess steam pressure due to failure of any control valve. Once the high steam pressure steam is admitted into turbine, It starts leaking through the front gland and flows in backward direction and increase the header pressure. From where this steam is obtained during starting and running condition of a turbine? During startup, shutdown and low load condition, auxiliary steam is used. During running condition, leakage steam from IP turbine gland is used to seal the gland of LP turbine. Why is the gland steam condenser provided? This arrangement minimizes the water loss due to gland vent, and its heat is utilized in the gland seal condenser to heat the condensate, and hence, the plant efficiency increases. What is bearing device and why is it provided? In a turbine, the mass of rotor is more. It is subject to high temperature also. So it is not advisable to keep the rotor at standstill position after the stoppage of turbine. To avoid sagging or deformation, bearing devices is provided in the turbine to rotate the rotor at slow speed. What is the function of jacking oil? Jacking oil provides high-pressure lubrication to float a heavy turbine or generator shaft on an oil film, especially during slow-speed operation like starting and stopping, or during maintenance. Its primary functions are to protect bearings from damage by lifting the shaft and reducing the breakaway torque, allowing for a smooth start and controlled shutdown by preventing metal-on-metal contact. What is the main function of a governing system? Governing system is a system of turbine to control the speed automatically. It controls the energy input steam to the turbine. Indirectly, a governor also controls load, exhaust steam pressure, quick response to small speed change, adjust control valve with minimum overshoot, have sufficient power to overcome the back force of control valve. Very little speed fluctuation under constant load and steam condition. What is magnetic pickup unit MPU? Magnetic pickup unit MPU is used to measure the actual speed of a turbine. Output of this sensor is directly proportional to the speed of turbine. When any magnetic material passes through the magnetic end of magnetic pickup unit MPU, a voltage is generated. Why is breaker contact used in a governing system? Breaker contact provides information to the governor about solo or parallel mode of operation of the generator. Accordingly, a governor acts as speed controller or auxiliary controller. Speed and auxiliary controller set point can also be changed from the remote control desk. What is turbovisory system? Turbovisory system is a monitoring system of a turbine. It also ensures that the monitored parameter does not exceed beyond the maximum permissible limit. Important parameters are monitored: vibration, bearing temperature, eccentricity, axial position. These parameters indicate the condition of turbine during operation. How are RTDs fixed into the bearing and where are these placed? RTDs are embedded in the journal and thrust bearing and placed just below the babbiting material to get the actual reading of babbiting material. Through RTDs, bearing temperature of all the journal and thrust bearing are measured. What is the difference between controlled extraction system and uncontrolled extraction system? Controlled extraction type turbines are used in process industries where steam is extracted from the turbine at a desired pressure and temperature after a certain stage. In this case, the amount of steam can be adjusted as needed. For this, HP and LP control valves are used, which open and close the HP or LP steam according to the process requirements. To increase the water temperature, an uncontrolled exhaust system is used in the Feedwater heater. This is called a regenerative cycle. The temperature and pressure of the steam at different extraction points are different and vary greatly with the load of the turbine. In this case, the amount of steam extracted is not controlled. Why are Feedwater heaters provided? A Feedwater heater is a heat exchanger used to preheat the boiler feed water by means of steam extracted or bleed from the steam turbine. Preheated off feed water improves the efficiency of a system. What is the difference between LP heater and HP heater? LP heater is located between the condensate pump and the boiler feed pump. Extracted steam from the low pressure stage of turbine is used here. HP heater is located between the boiler feed pump and the boiler. Extracted steam from the high pressure stage of turbine is used here. Define cold reheat and hot reheat. Steam after expanding at HP turbine is sent to the boiler for further heat addition or reheat. This steam is called cold reheat CRH. The reheated steam, called hot reheat HRH, is then sent to LP turbine where it expands further. What are the main functions of turbine bypass system? During startup, shutdown, and load fluctuation in a power plant, the boiler and steam turbine are required to be operated as per their individual safe limits. For this, turbine bypass system is provided. Turbine bypass system help in reducing the startup time by controlling the boiler pressure and temperature. Why is PRDS required in a turbine bypass system? Superheated steam pressure and temperature is much higher than that of the cold reheat. So HP steam pressure is reduced to match the cold reheat pressure and temperature. Like this, pressure and temperature of hot reheat is controlled while dumping in the condenser. For this, pressure reducing and the superheating PRDS system is installed. What is the difference between tandem compound TC type turbine and cross compound CC type turbine? In tandem compound turbine, 2 or more casings are jointed end to end to drive a single generator. The steam is partially expanded in the high-pressure casing and then exhausted to the low-pressure casing. A crossover pipe sends steam from intermediate pressure turbine exhaust to the low-pressure turbine inlet. In a cross-compound turbine, 2 or more shafts drive to 2 or more generators. What are the advantages of multicasing turbine? The advantage of multicasing turbine are: the size of casing reduces, highest pressure can be confined to the smaller casing, which is stronger and made of more expensive material, flow in the low pressure casing can be divided for equalizing the end thrusts. What is crossover pipe? Crossover pipe is carrying steam from one casing to other casing in multicasing turbine. What is the main advantage of multiflow turbine? If the steam flows only in one direction, then the turbine is called a single flow turbine. A single flow turbine developed high axial thrust. The flow of the steam inside the turbine is split into 2 directions. Steam from the high pressure turbine enters the center of the low pressure turbine and flows outward in the both directions through 2 identical sets of turbine staging. Axial thrust is balanced and is very less than the single flow turbine designed for the same capacity. Why is NRV provided at the header extraction steam line? NRV is provided at each extraction line to avoid backflow of steam for the safety of turbine. Where is the condensate formed at the heater's drain during normal and abnormal operating conditions? The condensate formed from the extracted steam after heating action is drained to the downstream heater. The condensate level of heater is maintained through a drain control valve. An emergency heater drain valve is provided to use only during the high condensate level condition. Through this valve, condensate is drained directly to the condenser or flash tank. दोस्तों, अगर आपको कोई टॉपिक चाहिए या कोई खास सवाल सीरीज चाहिए तो मुझे कमेंट में जरूर बताएं। मैं अगला वीडियो उसी पर बनाऊंगा। चैनल को सब्सक्राइब और शेयर करना ना भूलें। मिलते हैं अगले वीडियो में।